Good morning, good day. On this day, February 25th, 2021, this is your friend Engineer Suraj Singh, resuming talk about professional engineering quality related issues and title being Civil Field Engineering Designs, Construction, Methods, Contracts, AnnexSL, Organizations, Communications, Coordination, Quantity, Quality, and Why Quality. In sequence, a long sequence, this is talk 2275 probably, and quality again important issue for me and for everybody. Some people may respect it, some people may not respect it. That depends upon how you consider this. It depends on what you think about this. But quality is quality. It can't be defied, and if you defy it, you know you have to suffer. Everybody has to suffer. The quality talks are very high. It has been very high for long, for decades. But if you see return, if you see, if you see consequences, quality has not been working in products. It has been working in talks. It has been working in displays, but it has failed to deliver consumer quality product. And this I'm talking for all products coming from all over the world. There may be variations in quality achievements, but no product can claim that it is 100% quality oriented. And in many countries like ours, India, Bharat, I think quality spelling is missing, quality meaning is missing. It misses everywhere. You buy whatever product, you buy whatever, you will be given complete warranty and guarantee that this is the best in market. But when you use it, you will be disappointed after some time of purchasing whatever you buy. Electronic goods, not electronic goods, non-electronic goods, civil goods, other goods, buildings, whatever you buy. Means I think you won't be satisfied, and you will always regret why I bought this. But you have already bought it, purchased, installed it, and you can't do anything. This is my observation. Your objection may be different. I cannot assure myself that your observation is same as mine. But question arises. Despite being systems, despite being everything, every seminar, every talk, every writing, everything being available, why we are not achieving quality on products? It may be structure, non-structure, it may be finishes, non-finishes, and it may be whatever consumer goods. It has to be realized that nowadays we are far lagging behind, far lagging behind in quality approach. Those days were better when I was young, and we did not know what quality was, but we knew that we had to do right work according to requirements, according to specifications. Those days were different when people used to involve themselves personally. Now, when one person used to do on so many activities, that person was conscious, that person coordinated in itself. But now departments have been evolved. You have evolved many departments, for example, in construction itself, in engineering itself, in design itself, or you go anywhere. You go wherever you want to go and will find many sections in profession, and everybody thinks of itself rather than combining all. Collective approach has been missing somewhere, and these softwares and computers have kept people off from coordination. Highest reliability factor, highest reliability coefficient has gone to software, which is not right way. Who built software, what he data was fed, and what formula was fed into computer. We depend on that rather than ab initio working ourselves. Means what is from first principle we can say what does it mean, what does it stand for. If you try to work out your designs yourself without using computer, I think nowadays it's almost impossible. Youth who are coming out of university as budding engineers, I hardly, I think hardly they ever work out calculations themselves. They always are hungry for requesting files. I need this file, I need that Excel file, I need that one file, ETAB file, that file, this file, stat file. They are always in search of files rather than attempting self to do something before demanding or requesting others to deliver them. This has been very common. You can go to whatever structural engineering sites all over the world. You will find the same type of conduct by people. They are asking irrelevant questions on many engineering websites, on Facebook, which institutions indicate that they did not study well, they did not have fundamental clearance, they only passed out without having basic, clarified knowledge, you can say, trustworthy knowledge. Well, every new engineer does that. But a degree of learning, a degree of hunger to learn must be available. Means one thing you want to learn in jumping, and one you want to learn in flying, and one way you want to learn by walking. If you are flying, you cannot learn anything. If you are driving car, you can identify which shop you have reached, because your car is much more faster than the shop is situated. And you pass by, you are noticing this shop is gone. Same thing happens if you are walking, you can see everything. If you are running, you can see half or 1/4, and you are driving car, you may see nothing which you are looking for. So I think walking is only solution to look at everything. Maybe you people not agree, may not agree. That's up to you. But if you walk in some area, you can do best survey what is located where. And you just see, I'm driving car and see, and you will never get that location which you are looking for. That's what I say. It's a kind of another learning. Survey learning means I should know geographically what this area is. So you have to walk, and with concentration, of course. When you want to find something, you find 100 items cells there. You want to looking for one area, you want to see many more shops, many for offices, many for buildings. So you can say learning is most important, and if you do not learn, you can never achieve quality of products. Learning of principles, learning of theories, learning of applications, and you can say reading research notes, or having or sharing others' experience, and then utilizing all this for your own contemplation. I got this information from there, I got this information from here, so these are also valid, so I can use this, and once you use this, you would realize, oh yes, it is wonderful. Then you will have more attraction on that. That's called phase of learning. You cannot learn something because you want to do that your way. See, you cannot go beyond books till you are a student. In your university life, you have to depend on your professor's guidance and books, author-written books who have never been in field of practicality. They just read many books and they just give you notes or explain to you, and you guide that, and you further. It means there is no approach where you can say, okay, let's go to field and work for 1 year. This doesn't exist in engineering, at least doesn't exist. They may call now internship and this and that. Means those people who are not experienced, how can it be internship now? It should be practical. Means until you work in field for 5 to 10 years, and that too in projects. On projects, you may not get something reliable. I'm saying reliable is useful. If you don't have confidence in yourself, you cannot do something qualitatively and quantitatively. Quantity and quality both move together, must move together. You want to have quantity for purpose of progress. But if you miss quality in that, then you can't say I achieved this, because quality point shall defeat your quantity point. And your quantity point, despite being achieved, won't hold good, won't stand as a strength. So that's what I'm saying. One, you cannot, you cannot move your car with four wheels at different locations. Whatever locations they are designed, only on that it can move. If you misalign those wheels locations, car won't move. Same thing is here. Quality is like a car or product. If you don't care for quality, you don't care for this, you will miss every time. So my quality system says, okay, system is fine. You have to develop system, you have to write system. You can write system only when you know something. And if you don't know something, you don't have experience, even you cannot write anything. If I give something to new boy, come on engineer, you write this statement for construction, that person will not be able to write, because he has not experience in construction. How can you expect to write? Yes, he can write something imaginary which won't work, because experience must be drawn on papers after doing work. Yes, we have done this, and that written statement must be used somewhere else also, keeping view next design. So it is like that. You have to learn so much in beginning, and that learning goes on further in expansion, and you get more learning and more learning and doing and more learning and doing. So you got, you can say, kind of expertise in field based on practical aspects, because you are exposed to hundreds of drawings on every project. You are exposed to many new specifications, many new technologies, or many new methods, new people, new thinking, new approach. And every project becomes like a learning institution for you. Every project where you work for 1 year, 2 year, 3 years on a project, you shall find that this has given you a lot in learning, more than what you could learn in diploma or degree or 1.5 year post graduation or doctorate. Because it is a doctorate, means whatever you learn, you are applying from those authors or those experienced people's documents you never had a chance to study in your university or institution. And those experiences are practical one. Those will teach you practical angle. Those will, and you are going to take responsibility in field, in university or institution. You would not take any responsibility, and you will be guided by your professor, and your professor is not practically responsible, because your professor has never been in field. So that is only theoretical or tutorial talk, and I'm talking about this. This is field talk. This is talk based on real world of engineering, where when you show line of excavation and plan, but that line is never straight in field. So that's what I'm saying. Field engineering and book engineering are like earth and sky. It is must to learn that. Without learning you can't move. You cannot say that you mean that I should not go to university. No, you have to. You have to. But that is part engineering. That's not full engineering. Even though your certificate says you're a bachelor in engineering or master's in engineering or doctorate in this topic. But point lies in that is theoretical engineering. That is engineering to understand, engineering to enter into field, and not more than that. You can know where is house door or house gate, but what is inside house, you have to enter, you have to move, you have to see. Only then you can say, this house is like that, like this plan. That's important point we have to consider, and we have to rely on that. If you don't rely on that, well, I think you are in wrong track. Do not join engineering if you have no patience, if you are money minded, if your money is destination, if you do not have any mental status, if you do not have any conscious status, because engineering world requires everything, and particularly engineering world where human resources are very much useful, human resources and mechanical resources and materials are very much useful. I'm not talking about computer engineering or IT. I'm not talking of agriculture engineering. I'm not talking of electrical mechanical. I am talking of that branch of engineering which is based directly on natural materials. If natural materials are not available, there cannot be any such engineering like civil engineering or structural engineering. It's very important point to understand that civil engineering is exclusive one where you relate to nature, and without that relation you can never be civil engineer. From soil and from water to skies you depend on nature. Without that you cannot work. You need materials from lithosphere, you need water, you need air, you need sunlight, you need everything for working in civil engineering. Otherwise, there cannot be any civil engineering. And if there doesn't exist any civil engineering, we have to stay in deserts, in forest, in woods, in natural way without any kind of real development of areas. This point we must understand thoroughly. What does civil engineering mean? Do not take it very your way. Oh, this is civil engineering, this is very common field, but it doesn't give money. If you relate to money, you cannot live in civil engineering. You have to live in computer engineering, IT engineering, where engineering is only for namesake, not for real. What engineering is there? That is a science world, IT engineering. So you cannot compare to here civil engineering, which is supported by electromechanical engineering, and of course other engineering like architecture, like IT, and like all where other services are required to be inculcated, infused into building, so that building remains advanced one, speaking one, state of art one. That's very important point. We have to understand that what we think is not necessary what is available. Engineering never stops development, it keeps on moving, it always moves. When there was no such term, even that time engineering was working. As I usually say, God itself engineered this universe. God is top civil engineer, top electrical engineer, top mechanical engineer, top space engineer, top everything. You can say human engineer, everything. He has built this universe like undefined engineer, unknown doctor, unknown professional, everything is unknown. But that work which he delivered, are so durable that since the conception of this universe, since there was nothing, this world, this universe, our universes have been operating, and there will be no failure at all. That is very wonderful statement, you can say. I am relating engineering to nature, and that can be done. That should be done because nature is our teacher. No one else can teach us except nature. First teacher is nature. Second teachers of parent, and then other teachers. So nature teaches you not by not through professors, but through yourself. You are your own professor. If you observe nature, you will get so much secrets with you. No one can teach you, but it takes time. You can learn what is punctuality. You can learn what is regularity. You can learn what is non-stop. You can learn there is no rest. You can learn how system is working. You try to understand. This machine in which I am living, my body itself is natural product. It never stops in. Never ever. Did you ever notice you stopped even breathing for 10-15 minutes? You never stop. You ever notice your brain stops sometimes? You never notice. Your body is working, has been working since you are born. And it works time till time you leave this world. Not even a one single minute is allowed for this body not to work. That is really, a kind of top teaching. When you work for 6 days and 7 days, I have to take rest. It is rest pause after 42 to 48 hours a week. It's not possible to work that you have defined system. Somebody defined that system and still being followed. But we forget that that is only for physical body. Mind always works. Even if you sleep, your mind works. Your blood circulation works. Your body internal plant works. It doesn't stop. Body has internal plant, very big plant, which you cannot even assume. Even imagine that plant is more than what's the refinery exists and all that, and that automatically functions. We have to understand that point. These all are references to learn. What I'm talking here is very small fields, not very big field. If you compare with your body walks in, how does it work? How does nature work? Our sites are very small. If you compare to that, our cities are very small. Our villages are much more smaller. Whole world is very small if you compare to that. If you compare to universe size, if you compare to size of this solar system, if you compare to size of sky, this earth is very small. Very, very small. And we all living on earth. We say economy is earth. Materials are within earth. We all say that this is mine and this is yours. Somebody depends on reservoirs, few fossil fuel reservoirs. Somebody depends upon gold, somebody on diamond, all comes from earth. Somebody depends on minerals, somebody depends on hidden wealth we don't know. Those points must be well understood. That's point we do not understand. So we have to be a little smart in understanding all this. Means this is why I say analytical understanding. When I use term thinking or analytical, these are very much interrelated term, and if you can understand in your life at least this after getting educated, after getting all degrees, your mind should open, and your mind opens in terms of power of thinking, in terms of power of analysis, in terms of logical talk, in terms of reasonable talk, in terms of having certain clue and then talking. It's not I'm just speaking for nothing. I speak without any logic. I have no basic criteria successfully understood. But I say I am talking and listen to me. People will listen to you, but they don't value you because you have no basic. That's what engineering tries to teach you. Engineering education develops your mind so that you can think and use natural products. This is what civil engineering is about. Best use of natural product. And if there is no use of natural product, I don't find any engineering there. If there is no rock, if there is no soil, if there is no steel, if there is no iron, if there is no air, if there is no water, what shall you do? We are all free. In fact, all free. Water is free, air is free, sunlight is free. My body is free. Everything is free. I am not paying anything to the body. Am I paying attention to the sun? Am I paying attention to the air? No, I am not. Am I paying attention to the sky? I am not. Yet I am using continuous without fail service, without break service. That's what we have to think. There's no one to charge us from nature because we belong to nature. Nature, we are part of nature. So quality, this is quality thinking, you can say. Everybody thinks, dog also thinks. But their thinking, dog's thinking is not the same thing as human thinking. Cat's thinking is different, A lion's thinking may be far different. And human is human. Who has best instrument, best component, best part of body is mind. And their mind cannot be bought. Yes, it can be used. It can be used, of course, but it can't be purchased. Whatever thinking you do, you make thinking, you continue thinking, you will get more and more. You will not lose on anything. Your mind will work more and more. We want that type of quality of mind, whereby loosening something, you get something. You explain something to someone, you will get augmented experience. You will get augmented knowledge. You will get augmented confirmation. If I explain someone to somebody, then I explain someone else to somebody, and I explain that thing, then I'll get my own knowledge upgraded, confirmed, well thought. It's just like remembering 1 to 100 or A, B, C, D to Z. In beginning, maybe we claim, or later on we get, it's on my tips and this is my, maybe I can tell you when I'm sleeping. It happens. My dear friends, my talk is not to discourage you from engineering, but really if you want to do engineering, be an engineer. If you if you scale it out in terms of money earning, then you can never be successful in engineering. Many British talked to me when I was on sites that leave engineering out, no need of engineering. Why you are working in engineering? We are also working in engineering, but engineering is useless. Better do something else. He once suggested me, okay, you are here, you do some business, take tourists to your country, and that's better business than doing structural or civil engineering. Well, to some extent that was right. If you compare it to money earning, it's like that. Means money earning scale is different, but it is development only. It is your services are done for this earth. These services are done for products of gods that God put this earth, and this earth is a product of God. It respects God, it respects earth. I'm not talking going worship in temple or mosque. That doesn't mean anything. I don't care for that, but I care for that. I'm working for God's earth. Because I'm here because of God, and earth is here because of God, and whole source exists because of God. So if you make this up better from your own knowledge of engineering, that's what God ordered you. In fact, if you are in this field, if you are in some other field, that's different. Civil engineer is like, it's like a sacrificial person. Minimum salaries civil engineers get, that's also true. Minimum remuneration we get. And highest hard work we do. If you analyze the life of a civil engineer, I have written many times faced with the Alzheimer. If you want to be civil engineer, forget your family first of all. Because family has no connection with civil engineering, because civil engineering means remote engineer, means engineer working in desert, working in wood, working in countryside, working where sometimes you don't have any place to go for WC, you don't have any private room, you don't have any good water to drink. Now it's different, but at that time it was all about this. You had to even clean those areas where you start surveying. You have every bad item here. So that is civil engineering. Civil engineering means social-less, means you have to be society-less. I mean to say, you won't be in touch with society, you won't be in touch with family. Even if you have family, you will not be able to support. Of course, financially you may support them, but financially it's not enough. You have to support morally, you have to support them, consciously. That's what's required in family. Ties are different, it's very important ties. So I have seen, if you are in designs, you don't want to go out designs because you are comfortable in designs, you're sitting in good indoor service, you're getting good room, you're working on computers, no hard life, no struggle. So you say I'm a designer, with pride you say, but you can never work. You go on site, you go on to site and field and see work, because that's also your job. After all, you are an engineer. That is your first job. But you think, no, your design is only job, your planning is only job, your quality is you want to run away from taking responsibility. That's why you say like that. Your higher qualification doesn't mean you have to keep up sites. It doesn't mean that. You have to contribute more and more on that, because site work is your laboratory, site work is your factory, site work is your industry, and if you do not produce quality work, what sort of engineer you are? My question is that. Without knowing facts, without knowing practical aspects, nobody can be design engineer, nobody can be whatever sort of engineer in our disciplines. You don't worry about your tie, you don't worry about your suit, you don't worry about your well dressing. Think of what best you can do. What best? Means that's what's required. Engineering profession cannot be defined solely. In fact, there was only civil engineering one time. There was a time when other engineering was absent. Other engineering was absent. This was the reason that resources were not available, technology was not available, materials were not available. But as evolution moved, as it happened, we started getting everything. Until now, I cannot say that we have completed. Still, we know only top layer, assumed top layer of lithosphere, that is crust. Only in crust we have all metal, this metal we have minerals explored, extract out only from, you can say, few meters of earth. lithosphere, or maybe few kilometers, if not meters, and then we do not know what is in mantle of lithosphere, what's in core. We have only ideas, nothing else. So God has done so much in this sphere. The first of all, we are living in this sphere of elliptical world. We are using this for our lives, and we have resources within this. We know some and we do not know a lot. We know very little about that. Our learning of engineering, our dealing in engineering is very, very small if you compare to engineering of sun. How sun engineers its work. After all, God produced sun also, Jupiter, Mars, Earth, everything. So we have to learn from them. There's no sun is such an electrical power, you see, when it is on your end, it gives you light throughout day. All power stations of world cannot illumine what sun does. If you keep on all power stations in world, you will not find that light power as sun gives you throughout day. It's really wonderful. Means nature is so perfect, so long. If your body is so perfect, or it lives for 60, 70, 80 or 100 years. But you take eyes. Your eyes can see up to stars. It means your eyes are so powerful. This can view unlimited. They can live unimaginable. This point must be valued. Your mind is so powerful. Maybe you are now 80 years old, but still you remember what happened when you are 2 years old. When you are in your own memory, you recall what happened with you when I was in school, or I was in there and here. You still remember that point. And you still remember your dreams where you were don't even remember, but sometimes something you remember. So when I say these products are so durable, God has made them so durable. Your heart is so durable that it all times work. Now, why don't we understand system of quality from all these references, all these examples? Sun works and nature works and solar system works, earth works, everything works. It never stops. Earth moves on its own, rotates on its own axis, it orbits around sun, and it never stops. Means there is some arrangement in these bodies which God has put in some power. The quality works and performance it gives, and it's giving. Why don't we then learn very small aspect of materials, of products? Why we ignore it? My point of view is, why do we ignore quality? We are very happy. Oh, see, GDP is so much high. We are only interested in GDP. Is there any quality GDP? Does it exist? We say, oh, this is not good one, but everybody says, no, this is economy. Economy is more important than quality. Though economy must have quality. Means we only exploit natural wealth, and values of our currency fluctuate not because of goods available, not because of metal available, because our thoughts. Economy simply says whatever is hidden in earth, that is economy, nothing else. From where economy comes? It doesn't come from the skies. Economy is related to wealth, and that wealth comes from earth, the lithosphere. And whatever you have, that's it. Quantity wise, economy never changes. Yes, value changes, value of your currency changes, and that's why we say value has changed. We have relations to other countries' currencies, and that's why changes happen. My economy is down, I have less product or less valuable product, you have more value, so there's a difference in economy. That economy, international economy standard must be understood. See, whatever gold is available, that is available in earth. We don't know quantity. It will not go away, it will not change its quantity. Nothing happens, whatever wealth is available. So if you see quantity of wealth and then compare economy, economy never changes. And all material within earth belong to everybody. That's also true, but people don't say that. That's another weakness in economical understanding. I should not shift my discussion to economy. I'm just giving a reference for your understanding when I'm talking of quality. Quality exists everywhere if you realize that. If you don't realize, it doesn't exist. Whatever work you do in your life or in a profession, it should be qualitative work. But that qualitative definition must be defined. That must be proportionally defined to its use, to its products, requirement, what requirement of products we have, how it would perform, how it would work, deliver services to its owner. We call I am owner of this product, though nobody is owner, but for reference we say I am owner, or I am user, you may say, after buying you use it, end user, or real client, you may say real client, because hidden client at time of purchase, there was no client, but when you own this, you are client for that item. So that's what I'm saying. Quality is very different. It should be taken not in system approach only, it should be taken in real world approach. I'm not going to show quality to someone, I must be satisfied myself first. I must be satisfied myself that this is quality. Only then I can say, yes, it is. I have to consider what quality I am talking about. Where is quality? What is definition of quality here? Yes, I understand. It's not extensive. It should be according to your approach, according to metal that has to perform. That level of quality must be inbuilt in quantity. But here is where neglect happens. Neglect, it is, yes. I can say it is neglect. Neglect, ignorance, carelessness, or moving ahead without worrying. We'll see. In India, Bharat, there was saying, chalta hai, means okay, no problem, it moves. Even if you do something, it moves. There's some kind of understanding. Don't worry, it's within tolerance, it happens. That is some kind of saying in our country. It was, I cannot say now. It was a kind of saying, chalta attitude, means attitude was like that. No problem, it would work. Few centimeter difference, oh no problem, it would work. Millimeter difference, no problem, it would work. Means everything is working, everything works, means you make mistakes, it works. Yes, right? See, I'm just trying to explain what does it mean. Why I explain, because I'm finding absence of quality. And it's not now, it has been chronic problem in our country. You can interact with people, you find their opinions. Some people say no problem, it works. Even, I still remember one judgment in which some judge said, oh, 5 or 10% this way or that way doesn't make a difference. Because these people do not understand quality, maybe judge or maybe doctor, maybe whosoever. It's not their fault. The education system is like that. They don't understand its quality. Just doesn't mean everything, he knows everything. No, it's not. It's your profession. You are your own judge in your profession. You are judge. Law person is not judge. And you have to define your system. You have to define your orientation. You have to define your destiny. You have to define your objective. You have to define. And that definition is very much, interesting. If I define something, it's myself that knows it. So when I talk of quality, every day I try to explain something about that, because civil engineering field is vast one. Somewhere there is quality. If you see, now I'm not talking of our country, I'm talking of world. Somewhere there is quality. If not 100%, there is concentration on understanding, trying understanding, and where there are such countries where they don't bother about this. We are one of them, hence our country. You may say, I'm talking, it's a criticism. No, it's not criticism. It's speaking facts for, you see, after all, we are going to use natural product. God's given product. And this is like prasad. You know, somebody used to tell me, oh, I don't receive prasad. I'm eating food, it's prasad. I'm using material, it is prasad. After all, these are all God's contributions to humanity. Even crop is a contribution, iron is contribution, every material we use is contribution because we cannot make any material. Soil is a contribution, water is contribution, air is contribution, mind is contribution, body is contribution, thinking is contribution. Which is not contribution? Tell me. So we have to be with God, but we have to adopt quality system. Now system is in your hands. It's not in the hands of someone else. It's your own system, your own understanding, your own approach, how you reach there, how you move there. So only this was basics of you can say quality that I tried to share with you. Means my understanding of quality is that there's a limited quality and you have to define new limits. You have to define new limits for production and quality. It's quality. If product has quality, it depends on what percentage of quality it has, to what percent it meets requirements, and that if it's not 100%, it should be 95%, 98%, like that. Not 20% or 30%. That's not acceptable. Because a person who pays money, who pays the cost of that product, that person pays thinking, assuming that this product is quality one. If not 100%, to some extent it is. And it will perform to its basic requirements, basic properties. That's one, quality one. Quality system is other word, means I'm talking of quality controls. Quality controls must be done successfully with concentration, with continuity, but it doesn't work. It doesn't work. But if engineers intend to do this, there is no power which can stop it. Because system of quality is understood, is generated by engineers, understood by engineers, researched by engineers. It's they only who can work on this, not others. And working on it, thinking on this doesn't mean you sit down and think on that. During your working experience, you think, what should I see on this? What happens on this? You have to judge yourself, you have to think yourself and find solutions, intellectual solutions you can say, not blind solutions. Solutions which are based on logic, intellectual considerations and material properties, logics, understanding, and what to bust, what to limit, what's limit of using this material. And material world is very important in using quality, in using material under quality, and that material also, machines which are very important, which are material based, and those of course machines give us efficiency in working, but efficiency is efficiency until it is given due value, and if you don't value something, it won't give you that added advantage of quality. Quality therefore is entirely different world. Quality has a system which is known as quality system. That is also very wonderful because without system you cannot move. Your body is a system, your house is a system, solar system, universe system, sky system, or whatever you can say. System in body of woman, system in body of man, system in animals, system of sea, system of earth. Every working spectrum, every working sector in whole world is system. How rivers work, how seas work, how oceans work, how canals work, how ground works, how sun works, how crops work. There is some limit to our contribution, otherwise, nature takes off. Everybody is scared after some point. And that's where nature works. If you understand nature, if you respect nature, then nature works. And if you don't respect, it will never work. It will work like, naturally, which just like, this one is seed based crop, other one is natural, natural wood, where weeds come out, useless weeds come out, and we say this is not crop. So quality, I always talk of quality, not here, not today. For so many months I've been talking change quality, achieve quality, but unfortunately we are not moving in that direction with dynamism that we should have, with enthusiasm we should have, or we can say with proaction we should have. I'm not finding any proaction anywhere. Proaction missing in engineers, particularly in this country, and it is engineer community only that can change scenario, no other one. But our engineers are not having that much anger, anguish, expression of thought. They think others would do it, others think government would do it, and it never works. Our engineers, to be very frank, are very powerful, very intelligent, very much theoretical, but results, achievements do not corroborate what I say. These do not corroborate, and that's where problem lies in. So only solution is one should be fearless. One should be fearless when talking of quality, because engineer is engineer. Once you are engineer, it's responsibility that you should clarify your mind when required. If required, you have to give input from your mind so that actually working processes start. And if these do not start, you cannot achieve your goals. In construction, quality is of utmost importance and significance. If you do not value it, not value quality, your product of building, you might have complied with drawings given to you and specs, but you would never study them until you think, oh, tomorrow I'll study when it's to be done. I'll forget, I can't remember, I can't tell them what to read or not to read. But that's the initial point. Point is raised of continuation. Point is raised of your contemplation. Time when you start contemplating in university or school, at that time you can see you're getting some mind maturity levels. And there are people who do not know anything, 5, 6, 7, 8 people sitting on tractor or on trolleys somewhere else. And they talk of something after that. They have no explanation for real life because they stop thinking. They know everything. I cannot say that if you recall something, then you will answer that. Really, it's good if they answer, but it should be rational. You cannot say that there's one track, you go, you come, you go, you come. It doesn't happen. Therefore, quality is very much important for me as an engineer and must be for you as an engineer. Or not only being an engineer, it's important. It's important because we are human beings. We are paying money for buying whatever item we want to buy, whatever goods we want to buy. And because we spend money, our product we are delivered with should be reliable, should be to that class. Otherwise, there remains no meaning of this. So I should now move to quality talk. As systems say, quality systems, which is generally raised as follows: ISO 9001 which is quality standardization, and this system requires to be built by every company, every organization, or everybody who has a will to work in system or who already have been working. That system, what actually it says, in our own way, you can say, forget what books say or what they themselves say. Only, comprehensive result is that. Comprehensive result is that you have to do this. That's it. We have to do that. Nothing more than that. Something is defined, we should accept that, or we have to define ourselves. Then we must have experience in. If you think, my experience is fine, then your experience must be in writing. Because your experience should say what's required. Nobody would defy you if you are right. If you explain something to everybody, they will say, okay, person is an experienced and learned one, and you must try. The person says. That's what system is. You have to define your system. And not only define, you have to wait, define it, redefine it, follow it, and then see what difference exists. Certainly it would exist. That's where life works. It would exist. You can't say no. ISO 9001-2015, and obsolete one was ISO 9001-2008, which is gone now, and before that so many. This system is unique in its way, that it has added quality, responsibility to high-ups, which is wonderful. Because you cannot solely depend on first-grade people in companies where you have to drink water, you have to drink this, you have to clean some areas, and you have to give some food to people running that building or using that building. No possible like this. That's the different way of talking. I'm talking quality, system of quality. Quality control and quality system. Quality controls is a part that's not defined in the system, but that says whatever is today's mandate, that's number one to me. Number one to me. So I don't think there's any risk in that. It's only for namesake that we talk of quality. I have seen still our professors come onto my roof where I passed long back. I passed in 80s, so it is 40 years since I passed engineering degree. In those days there was no ISO 9001. So we have to either understand system defined by others, or we have to evolve our system adhering to requirements of durability or requirements of electrical and mechanical. We have to define system. Can we define? We have to investigate ourselves first. Can we define that system? Or we have to read other system and follow. You cannot even blindly follow because system is customized one. That system relates to some other item, probably market, and this system is system. Shopkeeper is there. He's trying to sell his units and complains also that prices of commodities have gone up. So we go on first to understand what is system. That is system based on IS 9001 and 9001 2015 criteria. That's very important one, and that system defines format of format of AnnexSL, which is very much important from Illinois to Dr. I. Actually, in quality system, it's a long run, very long run. That long run should be complied with. If you don't comply with that, you lose something. And that something is very important to be controlled. Quality system itself is a question these days. Anyone who are aggressive or powerful. So, So my dear, we come back to point of quality system that is very much significant, important, and that should occupy place number one in our engineering. Place number one, I say, we should begin with quality thinking, and we should have complete goal on banks of quality. Beyond doubts, it should work, and we can compare years. If we care for quality system, it shall care for us because we have devised the system our way. It's by experience, it's by continuous efforts, it's by after. And that percentage of successful quality that you put, that you feed in your words, is real quality, and it should be taken care of. Product quantity, product standard, and working of its own, or you can say product performance. Product performance is really very important point that we have to care of. Every product should be taken care of, and quality lies in the hands of people, in the hands of those who do work on this, and you take quality delivery. And for those who will stay besides that room or besides your room where quality exists, you will find employment for wages. Learning for everybody is very important. How shall we learn? It depends. We have to decide quality from each aspect, each consideration. Quality system that depends on certain format, what we have to understand, like method, we have to define everything. When we do some method before doing something, that we have thought on this, we have we have considered how far it should go, and we say this is 60% on average. how to measure your success of quality, in what way we should move, what is best way to measure it. It depends on what we perform. System is whole. Some person accepts whole system and some person accepts only part. Where there is no way frustration with. You have to think how to achieve 100% and even more. You have to move forward and remove all non-practical aspects, include all practical aspects. System that we devise have certain announcement, you can say. Those people who are hungry for quality, those who wish to move in this direction, they are better than those who do not think of this. And if we produce something without quality system, compliance, you can see that is no use, it's not admissible, it cannot move in those circles where we are required to move partly because of quality. Quality system was evolved by methodology of ISO 9001 sometime in past. Uh, don't be bored by requirement of quality, because this is very much boring. This is very much non-amusing, non-entertaining. This is very serious work. So seriousness must be respected for all other activities other than quality. And when we know quality, we understand it, we routinely accept that. We have to define it. Unfortunately, we have not defined it well. We have to define, we have to customize it ourselves, and then see how how different it is and how does it work. Quantity, we are interested in quantity, and we call it quality. If you define your system yourself and then move on that, you will feel very happy, very contented that it changed everything. Means mandate must exist. Mandate of quality. That has been missing. It must exist. And if we do not value this, we would suffer, of course, we would suffer. And that suffering, what we call quality suffering, we are suffering because of quality, and quality is suffering because we didn't value quality, and we spoiled all natural materials if we could not use them where it should be. This document which I am showing to you, this is called AnnexSL. AnnexSL, that is a standard format devised by ISO 9001 organization. I mean ISO, not 9001, ISO, which has standards of quality system, and that's called AnnexSL, high level language profile of language. It tells everyone that we have to follow system. When we say AnnexSL, it is structured into 10 clauses, and which clauses contain whole organizational system. Clause scope, that is number 1, to clause improvement, number 10, and there are very, very many, clause 2, clause 3, clause 4, text of organization. Likewise, you can say references, and 3 very other important areas. 4 is improvement. Scope to we have to make it out. We have to, like, fill in blanks, write ourselves. What do we need there? And there are certain texts available, there are certain methods available. We have to fill in and then accordingly follow it. Yes, it is quality system talking of. AnnexSL I'm talking of, which is very much important from each point of view of quality, each point of view of engineering, from design point of view, from execution point of view, or from all other all other management or organizational point of view. It's a kind of method that trains quality system itself. It sequences in all requirements on a piece of paper, and we, because requirements are engineering requirements are defined by all by you can say by by employer, and these requirements must be done, must be taken care of by engineers in field and in designs, from scope to improvement, and then it's from distance to positive messages to smile. Well done. We have to concentrate on that, and that is what quality system requires. And this is, I'm talking of EPC, EPC contracting facilities and buildings. We talked of scope, we talked of references, we talked of terms, we talked of text of organization, something we talked of like that. We will talk. I have taken only scope at length. We will talk of all number 5 as well, that is controls, or you can say a kind of, you may, and then EPC, which is very powerful contracting system, which gives everybody something which should be taken care of. If we do not take care of, it is something we miss, and that missing item has to be again taken care of. That's very essential requirement, and we must be ready to accept that. AnnexSL and buildings, we had gone through its system definition. It defines class 1 scope in this. It's a long one. We defined lot in this, and we had complete understanding of EPC and plants, what plants are, what we do about that, components of plant. We say components of plants, which are hundreds on plants, and every plant has different components, onshore, offshore relations. We had and of course we got all this understanding of various names, various equipments, various procedures, all these components we discussed. Which is a lengthy one, of course it's lengthy for such project which amount to billions of dollars. We talked about the references were also very long list. I'll just reach there and show you what we talked of there. Normative references we call them, and we talked about them. Then terms and definitions, we talked about them many we talked, and we'll go back to them just for refresher and come forward just to think of again and then explain again. It's to some extent, not thoroughly. And of course we'll then move to text of organization likewise, so that it works well, it does well. Meanwhile, we have to, I'm taking more time on EPC because it is very much worthy to take time on this. Reason being that it is design oriented. It is not simply contract of construction. It's a package contract. Package contract means it includes actually designs, it includes speed, it includes innovations as well. That is very much important from every viewpoint. We have to collaborate, we have to include. That is where engineering plays a role, high degree role, must be cared for. It must be. So back to you with quality again. Very much interesting, very much interesting study requiring everything. Quality conscious talk, which is very interesting one. If you really want to know something, it is wonderful talk. If you do not have any understanding, if you do not have any, you can say, if you want to know something about quality, about methods, about controls, about contracts, in this we talked of authorities, state ministry plans, we talked of statutes and laws, national and international standards. Then we talked of project descriptions, its leadership and its management. Then we discussed about project requirements, technical and managerial. Then project capacity in long and short run, in terms of production and performance, project management or organization at different stages from inception to its operations and maintenance, contracts management applicable for designs and for execution, prime contractor and its relation with company, design contractor and its relation with company and prime contractors, nominated contractors, execution contractors, vessels manufacturing vendors, site protection and security, maintaining site tidiness, maintaining site traffic controls, maintaining site all other controls, contract between company and prime contractor on specifically designed contract conditions, degree of extension of FIDIC, Red Book or other books like Silver to contracts, whether or not new engineering contract, SKSP or national standard contract applicable, or FIDIC contract documents related to prime contract, levies of contract, liquidated damages due to delayed deliveries or due to defective works and defective performance, levies of penalties during failure in life cycle of plant's facility performance, which could lead to shutdown of project processes partly or fully, legal liabilities between company and prime contractor in case of plant's fire leading to fatalities and heavy losses, international arbitration for disputes resolutions for all disputes raised in short terms as well as long term basis, company owners personal, engineers personal, contractors personal, all contracts including subcontracts, workforce requirements, daily progress reports on status, memos to prime contractor, technical clarification, engineering clarification, contractual clarification, subcontractors actually should be, and site instruction, engineer's instruction. Now, up to nominated subcontractors, okay, we had explained a lot. And site instruction, of course, site instruction, engineer's instruction, though these are related to construction contracts, but still equally important for EPCs as well because meaning is same, interpretations are same. So we can say site instruction, you can say in normal kind of instruction, and before that is also site memo, which is very ordinary letter, ordinary correspondence. I did not write in this list, though it's site memo, a kind of memorandum, a kind of letter given to contractor from engineer level or from resident engineer level, just for some call of some information or some whatever. It's not contractual actually, but site instruction semi contractual, means when instruction comes, I say for example some instruction comes in title site instruction, it said particularly in construction contracts it comes in, or even in EPC maybe, that engineer expects you or someone or I guess the employer expects you do this, right? It may be and you think that this doesn't fit in, and you are of an opinion that it doesn't fit in, and it's also written on that instruction that if instruction constitutes, if you are of an opinion that, if you have an opinion that, contract is an opinion that this instruction constitutes a cost variation, then you respond first and let it be decided whether or not cost will be considered, cost variation will be considered. That is called site instruction. Means it's an instruction, of course, mandatory, but its implementation is not mandatory. That if you think, oh no, I have to spend more cost or time on this, then you can raise a question and wait for answer. And if the answer comes, okay, we don't mind if it constitutes cost variation, you continue with this, implement this, and we will take care of your cost variation. Then within a specified period you can submit details of those costs, but you have to continue with that instruction. That's called site instruction. But before site instruction is implemented fully, engineer's duty is to convert that site instruction to engineer's instruction, which is legal document, because a legal mandate this gives you, and that includes your variation, of course. And that engineer would say, well, fine, it's my instruction, do it, and you will be paid for this, or direction shall be made for this. Generally, it's extra cost which is demanded, and that engineer's instruction is, you can say, it's a finance element which is legal, and that is claimable. Then the other one is procedural one, and that is a request for inspection general items. Other one is request for inspection concrete pours. Because major inspections are for concrete pours, and of course inspections are for general items. So general items means sometimes you take in writing something, you just say them, request them, send request, I want inspection of this. And means it's not major inspection, it's minor items, just even by sometimes walking on site can be inspected. But it should be in formal way, it should be documented. General items are hundreds, while concrete pours are limited. But the only difference lies that general items are simple in nature, while concrete pours are well defined. You have to you can say you have to refer many documents, many drawings, many specifications, and many method statements, etc. for inspection of concrete pours. It may be big slab pour, or it can be columns, or it can be beams, or very small work foundations. So those pours are called concrete pours, and general trend is that on ordinary speed work 24 hours are given for concrete pour inspections, and you have to notify them. Sometime before it was 24 hours for general items, and more than that, that's up to 48 hours for concrete pours. But practically this doesn't work, very frank, because you can't wait for 48 hours or 24 hours for small inspections. So practically it was 24 hours for concrete pours, and whatever time for general. Means when inspectors are oriented on site, they stay on site. Means there's no mandate. If there is rush of work, you can say yes, it will take few hours for inspection, and for concrete pours, yes, it should be some time, because one inspector or one clerk of work or resident engineer shall take. There shall be for you can say level inspection. There shall be coordinate inspection. There shall be shuttering inspection. There shall be steel inspection. There shall be electrical inspection or services inspection, or various types of inspection. That methodology demand, and before pour again the inspection of cleanliness, all that. There are many ways, and from where we're going to buy concrete, batching plant. Like this, then there will post concrete inspection. So you can say request for inspection for concrete pours is a package inspection. Not one person is there. There are many, many engineers, one by one. Electrical engineer, civil or structural engineer for steel, for formwork. For it depends on size of your inspection. If there's a many 100 cubic meter of concrete, of course there shall be many people, and there will be relook also, because during inspection points are observed and these points require to be corrected. So that's explanation of request for inspection of concrete pours. Then other one is that there is defect. You cause defect. You cause defect on works, and defects cannot go unnoticed. Actually, it can go unnoticed, but I think that's not professional way. After all, this is if you are a contractor's representative or contractor's engineer, you should not think that I'm a contract engineer and my duty is that it should be passed. Well, that if you think that way, it's approved by consultant or it's approved by our quality person and that works. I think that's wrong approach, because everybody is responsible for bad work or good work. It may be yourself, you are responsible for producing work because you are a contracting person. So you should know much better than everybody else knows. That is what I understand. You cannot run away, oh, that person will inspect, I don't care for this. Cannot say that. I have inspected, but that person is available there, that person shall find out mistake and I will correct this. If you have that tendency, then I think you are deficient engineer. You are not an engineer, you are not a leader in yourself, but you are wrong somewhere. That point should be understood clearly. An engineer, you may work for contractor, or you may work for consultant, or you may work for engineer, or means wherever you place yourself in, inspection remains same. You inspect or somebody, you are inspecting because you are doing that work. You are producing that work. So first responsibility goes to you to declare that work is done according to requirements, and then you have to prove these requirements. If your requirements are not proved, this means you are not concentrating on work, or there is a lack of competency in you. One time, first time, second time, 2, 3 times, if you repeat same thing, that's a person is not competent in quality world. Person does not understand what to be done, what not to be done. And how can they expect methods written by you would work? Because you are not sure. You are not sure as contract representative about what should be done, what is quality, what is requirement. If you lack in requirements, you might have you are not gone through contract documents, you are not gone through specifications, you are not go to standards. In that case, they will not teach you. It's not their job to teach you. It's your job to learn. Therefore, if you repeat, it's called non-compliance. And okay, one time, first time, second time, they would help you because everybody has a right to learn. But if you become habitual of that, certainly you are not qualified to work on that project or that project. And if your non-compliance report keeps on rising, maybe not in papers but on site, so it indicates that this person is not quality person. That's what I want to define. Non-compliance reports, many non-compliance reports clearly indicate that site is not working smoothly, you make progress and you cause defects. As much progress you make and you cause many non-compliance reports, and these non-compliance reports are actually black mark on your performance, because you have to make on these reports methods, try to propose how to correct those errors, those non-compliance, how to bring back to compliance. And this takes time, this costs time, money, material, and it's very expensive. Non-compliances are very expensive. We generally call them in short form NCR. Payment for those items and those follow-ups can't be allowed. And when payment is not allowed, I don't think there's any purpose of contractors. If you're not allowed to payment for that NCR, until NCR is cleared, you waste time. So that is sole purpose of NCR, and I think it is job of quality inspectors and engineers as well as consultants that this must be recorded. Simply, you cannot say I'm a quality engineer, I observed this, recorded that, and those people did not take any care. You must issue NCR. Okay, if you do not take care. Okay, one time notification, verbal notification, or twice verbal notification to work, but when you see that there's way to avoid or ignore that instruction of non-compliance, you must take care. You must apply in writing, keep on record NCR, and seek solutions from contractor. And if it is neglected, then it's your role as quality person in the organization to take further action. Then material approval request and drawings approval request. Now, why we make requests for materials and drawings when we know these materials are to be used? Everybody knows materials are to be used, but question arises, which material? In some organizations, list of material is included on documents itself, but with, of course, exceptions, options, alternatives. Let us say somebody gives you 3 or 4 names of materials and manufacturers. Use either of them. This means this is called a shortlisted material list. Shortlisted. The employer has decided that I have to use out of these, or of course equivalent. That of course equivalent is there, but in fact that list indicates that we have these options. You select one out of these and make request for approval. You know, quality requirement criteria is defined. What sort of material we should have is defined. That is defined in general specifications everywhere, and whatever tender says, bid says, or contract says, defined. And when you have signed contract, this means you have agreed to terms and conditions of contract that will provide this material. Then option is yours. Now, how much financial difference there may be, that doesn't come in. Once you have agreed, we will provide one material out of these 4 requirements or alternatives. So you have to submit to your client through engineer that this material we are going to use. A format exists of that, in which material name, material discipline, material location on drawings or elsewhere, which is specifications applicable. Likewise, which is manufacturer, where is, and if some more information can be given, if some sample can be attached, or reference of material according to manufacturer's list. And then you can say if there's some data sheet or written materials as well along with sample, and you can submit that form with all details attached. And if it belongs to this category of defined materials, it's good. And if you say no, it's an alternative to all of them, then you have to include comparative statement and also give reason why you are interested in alternative. Why not one out of these 4 or 3? There could be reasons that you are not able to do that because all these 3 companies have closed down, this manufacturer, or there's They're giving charging too high prices in comparison to market. So sometimes what happens that these manufacturers know this item is included in this project and they have to take it to convert me. That's not right policy because it's a kind of suppressing contractor. When you have option, you should use option, or if you have a better product than all these products, you prove it's better at same cost and you have got this. That's what material submittal is, and then after you submit, engineer goes through thoroughly on that submission. If there is sample study or it's required, can call that manufacturer through you to seek more information. So that complete record is made, and that record is permanent one, and then material is approved or approved with comments, and comments can be incorporated after you get more information submitted. So that's way you can say this material approval request works. Also, I am titling drawing approval request. Material is one part that you have to procure, you have to buy, but drawing is something else. It's a technical work, nothing to buy. Only that you must have all drawings, all schematic drawings or contract drawings with you. Must have studied all, and you must have studied discipline related specifications, general and specific. General particular, you know about that. Out of that, because it is multidisciplinary drawings, multidisciplinary in the sense that many disciplines work on projects: electrical, mechanical, civil, plumbing, services, electronic services, gas services, CCTV, you may say, SCADA, or access cards. So many are these, punch card we call them. All services are different, and some services are embedded in concrete or in walls, and without embedment you cannot do the services. So before how to work on site, though it is shown on drawings, services engineers pertinent that discipline produce some drawings that indicates how we shall work on site, and those detailing of every part of drawing, if every part of full drawing, if it is full, must be drawn from practical working point of view. These engineers know better than what I know. Then this is submitted on different form, like material is another form, drawing form, which manufacturers is not important. References are important because putting drawing there at this area of work is important. And likewise you can say references of if specifications are applicable, and that's what called drawing submittal. It can be for every discipline. All discipline including structural, sometimes structural drawing is also required where something is missing or something is coordinated with the structure. Yeah, it should be. It happens. I still remember that I was in charge of coordination. You can say I was in charge in office engineering, or you can say technical engineering on a project a long back. I think it was in 2002. Yes, when I was there in that project, as I completing fourth year, I think fourth or third, I remember. I joined this in 1999, 2000, 2001, 2003. Yeah, I think end of 3 years on that site, on this project. And I was involved in coordination, office engineering, communication, and technical role completely. There's so many roles. including method statements, drawing of statements, writing. So there are so many utilities services and utilities manholes, about 400, I can remember 400 or more. At least I'm talking of only manhole chambers, not other services. And those manhole chambers means these were oil disposal chamber, water disposal chamber, rainwater disposal chambers, like many such. And we had to, somebody told me, don't, I know you ask me, I'm expert of this, and we'll see how to conduct, because this big job, 400, more than 400. I listened, I said, okay, don't worry, I'll take care of myself. I'll try my best. If I require some hope, I've got some help, I'll be present here to request you to help me. But I thought how to do that. There can be no uniformity in drawing, because it's underground work, below ground work, which is we are doing utilities. So and there was a precasting method we had to adopt. The installation of site, though it's not mandatory to precast, you could do cast in situ as well. But they were interested, site engineers were interested in the precast, because there is better control of precast right now. Well, I agree with that. So then I started one by one thinking how best it could be. There's some standards, specifications for that, and we try to do that. To block out inside walls in your manholes to come. What level from base level of manhole to pipe level of inlet and outlet. So there are some standard requirements. So one by one we did, and I started getting this approved. And I think it took many months, of course, but more than 400 sketches, each sketch having about elevations, 4 elevations inside one plan, 5 minimum, you can say 5 or according to openings coming in, means let us say 4 or 5 sketches for each drawing, all worked out, levels mentioned, dimension mentioned, depths mentioned, level mentioned, cover mentioned, sometimes 2 pipe, 1 inverter, so 3 pipes, and relevant coordination with other services. So it took took time, but I did work on that. Or I don't exactly remember, 400 more drawings myself of CAD. We did that, and each was approved after approval in form of site technical query. We used to call it site technical query. Means we propose this our drawings, we approve that. Those company of EPC, prime contractor, main contractor, review it and used to approve that, and then we used to send it to site for taking action. So one by one we did it. This was one big part of that utilities project or ethylene project, where all these 400 sketches were drawn one by one. One day I'll show you all this in talk, how we did it, so that you know what it was. At this moment I can show you, but that is because AutoCAD, and I had to either convert them to PDF, which takes time, very much time, then I have to show it to AutoCAD itself. I'll try to show you few by maybe converting to AutoCAD to PDF. We'll see how it works. I cannot say at this moment whether 400 drawings, and I cannot show all as well. All I can see chamber, oily water chamber, oily chamber, catch basins also is called, and so many like that. That's what it calls shop drawings. That's why I'm giving drawing approval requests. These are even drawings, shop drawings, and structural drawings as well. So of course, reinforcement details was standard one, so that was taken care by site guys. I was giving them just labels and everything, like the pipes come in, opening has to be this much, and if there are steps, where steps should be, and what should be covered about standard details of cover slabs. Also, there's a drawing approval status, drawing approval request. I'm just trying to explain to you what was done in field. Very important part. Then we come to subcontractors approval request. We can see on every project you are main contractor, then you may be civil contractor. Well, likewise, then there would be either your main contractor EPC or your civil contractor EPC, or you may be main contractor. You shall have to take services. You shall to hire services of all disciplines on that side of project, because maybe either you don't have your own people, if you have your own system, your organized organs of those services engineering, then you can engage those people in your house company, in the house company, and let them be working with you. Or if you don't have that, then you have to hire people, hire subcontractors from market, who are of course on list of approvals or who are very competent. Then you have to propose them. You have to propose those mini, or you can say small contractors, which are called subcontractors, to your client, and then they will approve. Okay, fine. So those subcontractors are approved. Their people are approved. Their organizations are approved. Of course, they are already approved by licensing, but you have to see, this client has to see pre-qualifications and the competency, which is a very important part on their credentials. And they are approved means there will be many contractors. Similarly, electrical, mechanical, or whatever kind, irrigation, you know, you may say, you can list any number, maybe 10, 15, sometimes 20 of services, and others decorations or other one. So that point must consider. After that, temporary works, permanent works, preparatory works. I explained this many times. This is very much important point, and we should keep this in mind. That this is not an ordinary point. Very important point it is. Very important point it is. Without this, you cannot do anything until you understand them. Temporary goes to preparatory, and preparatory goes to permanent, and permanent is permanent, which is deliverable. Temporary is not deliverable, preparatory is not deliverable, permanent is deliverable, is a part of project delivery. So what is temporary work? What is permanent work? What is preparatory work and what is permanent work? I think by nomenclature of this terminology, you know what is temporary. Temporary means we use that item, and then take it off. From there, after work is done. What work is done, that is different, but its work is done. Example is, scaffolding. Let us say it's an example. It could be heavy work scaffolding, or it could be access scaffolding. There could be access route. There could be, you may say, access stair, ladder, or railing, or you can say whatever safety measures we decide to take to protect people from accidents. All such items come into category of preparatory works, and category of temporary works. These are all temporary, and expenses on this all are included on project cost. So there is no one example of temporary work. Many examples are there, like ramp to go to trench, or put ladders in excavation pits, or you can say dewatering is required. That's also temporary work, and you have to do that. Of course, is included in pricing, and whatever kind of temporary work we can say that supports preparatory works. And preparatory works means preparation of those items which are required for permanent work. That's preparatory work, you can say. For example, if you just take you are working on a column, you have to scabble joint. If it's from foundation, there's scabble joint, so that you can do new the concrete of column. You have to install steel reinforcement as well as concrete. So activity of installing steel reinforcement as well as activity of concreting pour, both are permanent items, but there are other items which are just to allow this. Allow what? Allow, making construction joint at that head of column, then putting steel in, placing steel in, cutting and placing, reinforcing bars after cleaning of old cement, and then closing in with that box of your shutter. It's center line both ways and verticality, and to make sure that everything is checked. That point is called preparatory works that you are going to prepare for doing permanent works. There are so many preparatory works items in all projects and preparatory, and these must be taken care of. And after doing concrete, you have to remove those preparatory works like shutters you have to remove, and then again clear site. So this is what preparatory works tells about. Same way, permanent work. Permanent work means item that shall remain with project forever, like brickwork, block work, your RCC combined activities, your past sleep, I mean to say your past works, which constitute your present work. So temporary, preparatory and permanent are classified like this. You must understand them clearly. For permanent work, you can say so many tests are done, so many reports are demanded, and you can say all this, analytical items. I'm saying how to analyze this. Permanent works have no limits, preparatory works have no limit, and temporary works have no limit. All safety activities, HSE that we call, health, safety and environment, are covered in the temporary works possibly, but these are very responsible activities. Responsible along with temporary work, responsible along with preparatory work, and responsible along with permanent works. The safety, health and environment are attached, along with quality, of course, quality in all these, and preferably in permanent works. Safety element as well as quality element must be built in. That's what we say, freely, free mind, free thinking. You can achieve only when you take care of this. Take care of such provisions. This was only purpose to explain about these three classes. Then we go to construction method statements. Construction method statement. Really, it's very much interesting to think of construction method statements, because our people are not very much you can say interested in such items. I think we don't have such specific system to share with, or you can say to do this with, which is a drawback. We may say is a drawback. Drawback which should not be there, but it happens that we don't have. I thought I should share with you something, but a PDF I didn't find. PDF of that. I'll try to get immediately if when I can get. That is for purpose of this. It must be there somewhere if I can do this. I like to give something to you which maybe it sometimes takes time, but you can say it's important always to be I don't know whether I'll be able to do that. Let me try if I can do that. I got something here. Let me see if I can. PDF. Maybe by chance I got that, I'll show you. Exception crossing PDF. Publish. Let us see. Publish. I think you may get it as PDF of that. I just did it. You can see it now. I think you can see that. It's building practice for professionals. This is chapter 3, excavations and crossings. I think you're viewing that, right? I am sure you're viewing that. And this is excavations crossing, and let us say it. So it's just safety general. It is, excavations and crossing, MS1, site preparation and earthwork. Index is there. You can see scope, reference, documents, definitions, responsibilities, safety method, equipment management. Then this is index and this is scope. Purpose of this method statement is to define sequence of activities for site preparation works related to company petrochemical project. Extent of these activities are defined upon attached site plan, not included with this statement. Now reference document. PSM stands for Project Site Manager, CSM Customer Site Manager, like Customer Superintendent. All these designations are shown in this. And then execution crossing, same things. Responsibilities are defined here. You can say of all these people, safety. And then you can say production output procedures, equipment. Then another method is there, protection of existing services, similar permit, and then again you can say like that. There are so many methods given in this. I'm just showing it for reference that each item is written like that, which must be, we'll take care of that later on. I'm not, the only purpose was to show this Howard's method statement. Otherwise there was no need of this. I'll discuss with you later on. I just tried to show you. For this talk. And we will see what these are. Construction method statements, which is very important part of construction. Maybe you know that, but writing method statements, conceiving methods, without that we cannot say we are doing quality job, because quality is considered pre-considered in that, and methods are recorded accordingly. Safety issues, and you can say all issues which are taken care of here in this talk are all interesting one. So construction method statement is a domain of engineering. That domain is very important one, and we must take care of that. Construction method statements, and we can say standard working design or details. Standard in construction method, I shown you format. Means scope was there, first safety considerations and scope, then references, responsibilities of professionals, or can say staffing, their duties, then procedures, and then which material, what is procedure, what is attachment, I mean machines, etc. we need. That was method contents. Like we are saying here, format of AnnexSL, that is format of method statement. And standard working designs or details, standard working designs or details. This is also very important from repetition point of view. Certain sketches, certain sections, which may be repeated 100 times or many times on project, and those are taken out and standardized. Or some departments, some services departments or some structural departments use their own systems, methods, or some even codes give something. So those standard drawings, we call them working designs. One section is given and the section applies to many sections, many areas of project. So you repeat them, and that's called standard drawings for that project. Standard designs or detailing for that project. Sometimes the standard is that we give bar shape. For example, we say 446, it was sometimes in British standards. That is before 8866. That is in British standards of how to produce bar bending, bar cutting and bending some shape. And that's also a kind of, you can say, standard working. We just give bar shape, name, code, and then A, B, C, D is given there, and that dimensions are given, shape is known, and bar bender or bar fixer, steel fixer will cut accordingly. Cutting length is also given. We need not worry about that. Just you can make Excel sheet, you can write that code name, code number, shape, the ABCD, and there is a cutting length after infilling formula, means you have to formalize that, and then you can say this is my length, cutting length, and you have to do this shape, and of course if you've done, and you even can extend it further if you wish, that this is quantity of one bar, means that's not part of bar bending schedule, but you say this so many meters or millimeters are coming in, and per millimeter per meter this coefficient of weight, and then you extend that one further, it will give you weight of that bar, and you add 5% variations or cutting or working adjustments. Wastage is called. You get total length, total weight of bar, and how many bars are required there. This is weight. So you will know weight of that element you are working for. This element shall have this much weight consumption, weight requirement. So you can extend those, but minimum is standard designs and can be further used, and that's what's called efficiency. Then we come on to quality management, and this is standard designs for many, for waterproofing below ground, waterproofing above ground, roofing details, or you can say foundation details, or connections, floor connections, different floor connections, door and windows fixing details, or door and window standards. This depends on what design that works in. So that is what standard works designs and details. There's no one. There can be how many number, I don't know, you don't know. It depends on what type of project you have, how stairs are taken care of, connections between beam and columns, how will you fix on site specific standards for transfer of moments from beam to column. This can be standardized as well. What additional bars you use there, maybe not shown in drawing or shown in drawing, and they everywhere you repeat like that. Bars coming from main fixed beam, permanent beam to column, of transfer of movements and columns to the next one, like that, and how slab is connected to beams. Means these details can be covered there. And we can say that okay, that's fine. Now we're going to. This is standard working designs. Now quality management statements, including checklist and ITP. When we say quality management statements, quality organization statements, or quality requirement statements, these are very much useful. And checklist and ITP means there are hundreds of items they have to check in, and if nothing is documented, what to check in, everybody will do on its way and confuse also. So it's duty of quality department, quality section on site or from where it's controlled, that you have to, maybe there are 100 items on site, 100 standard items, 50 items whatsoever. For every item, one has to make sure that what's done on site is according to quality requirement, workmanship requirement, both. I'm saying quality and workmanship because workmanship is also part of quality. You can say quality requirement is that checklist must be there. If suppose you are going to check foundation or you are going to check excavation pit, what shall you do? There must be some checklist that you have to check these 3 or 4 points, 5 or 6 points, or so many points. The list is there that you have to. Maybe it's written already there on that checklist. What you have to check it, tick or not to tick, cross it. And then you can say ITP, inspection test plans, or how will you inspect, what's plan. So checklist and inspection test plan, a kind of document, format document for every item. For concrete it's always given, all what I explained to you, what's required, label check, alignment check, dimensions check, shuttering check, scaffolding check, steel check, electrical check, whatever is there, all must be taken depending on what element it is. If it is format for foundation, it's format for shuttering, it's format for beams, it's format for slabs, it's format for whatever. General concrete can also be said that. Block work can also be stonework, block work, or roof. I mean to say, depending on intensive checking you want to have. Some items are visible, some items are not visible, depending on that. Plastering can be similarly checklisted. There are so many points in plastering also. For example, you have to chase, first you have to see wall is in alignment, and to chase the joints, then you have to fix leading on that exponent or others. And then you have to do many coats. Likewise, you can design your ITP as well as checklist. So it depends on how much you have. I'm not saying you just burden site people for this. Burdening will not work. Justification shall work. You have to check minimum but for maximum controls. Minimum check with maximum controls. You have to check in such a way that controls are pulled in checking. You need not define same thing again and again. You need not check same again and again because it takes time. One check may be used for 5 items. That depends. So for example, column verticality or column dimensions can be used. The once you check, it's used for concrete, and post check also you can check. Then hacking, you are doing scabbling and plastering on that. You need not check verticality again and again. Until there's error, you can see by eyes that there's some problem which can either be corrected immediately or it can be used, it can be written in form of NCR. So then you go to safety management documents including safety management, induction, training, upkeep and surveillance. This is safety, we generally call SH, safety, health and environment, SHE, which is of course separate domain, but it's a part of contract. Safety clearly says safety is first consideration, and safety is a responsibility of everyone, irrespective of what discipline you are, irrespective of what status you are. If you are stay on site, work on site, then you are responsible for that in general. So you have to manage safety management documents, including safety, induction, training, upkeep and surveillance. Means when you join a site, however you are, however big you are, or however small you are, there is a process of safety, procedure of safety. You have to be inducted to site after knowing about that safety which is specific for that project. Or you may be knowing, so it's sort of refreshing, very elementary to highest one. Then you have to have training. Means training is not very long, it's only few hours, and upkeep it and surveillance. Safety is different for it, but it's very much part of project, and you should know this. I have already talked about safety in my many videos, many past videos. There are so many safety videos. If you are interested, you can go and see there. Then it is fire prevention and suppression, and that's very important part of contracts. Fire prevention and fire suppression. Fire suppression means once your building is on fire, structure is on fire, how to get rid of this, how to extinguish it. That's called suppression. And others, fire prevention means do everything possible. The fire is not important. I mean to say, you do something that nothing is left for fire to occur. We call loss prevention. We call pre-measures. So many ways means fire. Like there should be no loose wire on site, loose cable on site. There should be nothing as such as short circuit. Or I take every measure possible that electricians and safety people will tell you. We go on to administration, where all management staff, working personnel would stay. Administration matters means any problem with anybody, food problem, messing problem, sleeping problem, health problem, doctors available, sometimes ambulance is available. So yeah, that's very general measure which company is responsible for ultimately. Then there are so many other, I'm not going to extend this. Now, supporting executive references. So what we have discussed in this, let me repeat first all these 52 items so that you may know what I said. Authorities, state ministry, plan number 1, statutes and laws, national, international, project descriptions, leadership and management, organization, project requirements, technical manager, project capacity in long and short term. Tidy, tidiness and maintaining of site traffic control. One of the controls, very important point in traffic controls, actually defensive traffic. There, no offensive driving is applicable on site. A contract between company and prime contractor specifically designed contract conditions, degree of extension of FIDIC red book or silver book or other book, whether or not new engineering contract as case may be a national standard contract applicable, contract documents related to prime contract, levies of contract liquidated damages, contractors for all contracts, including engineering clarification, Contextual clarifications of contractors, nominated contractors, site instructions, then engineer's instruction, request for inspection general items, request for inspection concrete pours, non-compliance reports, metal approval requests, drawing approval requests of contractors, approval requests, temporary works, preparatory works, permanent works, construction method statements, standard working designs or details, uh, quality management statements including checklists, ITPs, safety management, organization documents including safety, induction, training. Means something to be site related and real, that is supporting executive references, surveys, land, and bathymetric. Let me see how many points are there so that we can move fast on that. 37 points. Let me first read them so that you know what I'm going to talk about. Surveys, land, and bathymetric. Battery limit demarcation, battery limit demarcations, excavation, all types, then soil testing, exploration on site, all ranges, soil improvements, all ranges, blinding concrete, concrete protection, waterproofing, below ground and above ground, cast in situ concrete, form work, all types, reinforcement fabrication, reinforcement placement, precast pre-stressed concrete if included, concrete glass reinforcement grade, structural steel, soil backfill, piping at all types, concrete block walls, roofing all involved types, plastering, rendering, flooring all types including raised one, blast doors, windows and ironmongery, kitchen including messes, wet areas, finishes all types, special items depending on requirements, performing testing and commissioning, design estimated quantities, issued for information drawings and design issued for building permit drawings if relevant, generally on plants, areas, buildings, permit would not be required, issued for construction drawings, revised designs when equipment is finally decided, giving complete technical details, then you can say national annexes, nationally determined parameters, published documents, and all other necessary definitions. So we are going one by one for small explanations. These are very much, very much useful. You can say. So supporting executive references. I said surveys, land and bathymetric. Survey, what is survey actually? Do you know what real survey? Do you think only level or theodolite or that is survey or something else? This survey we are talking of gross survey, fundamental survey, basic surveys of whole site, land survey actually, whole site survey, whole plot survey, and that is not only superficial survey or ground survey, it is surveys related to underground services as well. We may not call it geotechnical survey, or may call it geographical survey, and of course it can be, if it is geotechnical or geoservices, both are there. You can conduct surveys of contouring, surveys of its substrata, say one or two, or where you can say some services are expected. Then bathymetric survey where C is involved, how it works. These are very general terms I'm using just for information. This kind like that. Not going to do total detail. Means geographical survey will tell some drainage or some other electrical survey, some other thing in that area. All locations will be fill in, means if you are going to doing work there, maybe some well, old well, or whatever unrequired excavation is there, or something, you know, that is not expected, like, of course, soil investigation will give everything, but I'm not talking of soil investigation here. It's from your area of work, or you may say battery limits demarcations. Battery demarcation means where end of the plot area is, we cannot go out of that, have to work within that one. Battery limits demarcations, you have to mark out complete your area, battery area. Now excavation all types. Excavation all types, what does it mean? Excavation without which nothing is possible, in engineering at least, you cannot do anything. And that excavation is important one from every point of view. When you say excavation, of course you have to see if some services are underlying, if there's some live services, or you have even, soil investigation report, which would tell you so much about excavation also, which is data you are going, maybe you are going to excavate 2 meters, 3 meters, or 1 meter, more than that. What type of soil it is. In some cases, this very loose soil, which makes excavation very easy. In some cases, this may be water ground, but we are going to do EPC services, EPC oil plant. So I don't think water may be a factor there. And even it's a factor, you have to keep water out. If it's sandy, you have to excavate by whatever means you try, and that happens. So excavation, all types. There will be excavation in loose soil, there will be excavation in soft soil, there may be excavation in water, there may be excavation in clay, there may be excavation in rock, soft rock or hard rock or medium rock. Depends on what sort of excavation they are going to do. So that means if it's rock, it takes a lot of time. If it's loose soil, it can be bulldozed. It depends upon that, what soil it is. And that's why we are. Excavations type means, then, I experience excavation so much water available that you have to keep area dry for long. By rewatering, expensive item. You have to provide probably well pump system if it is that type of soil. Or if you have to provide submersible pumps as well. soil testing, exploration on site. Soil testing or soil investigation all ranges, because this is big contract, big cost, and there will be so many deep foundations, heavyweight foundations, vibratory foundations. There's going to be unlimited requirement, and soil testing is only answer to know about existing soil below and at ground, for which exploration is a must, investigation is a must. If you do not do this, you are in the wrong boat. Means soil investigation at maximum level, maximum requirement must be done for this work. Soil testing is very important activity with which we should start our work. Soil testing for such a big site, maybe 2 km by 1 km size, 2 km by 2 km size of that plant. So we should do extensive soil investigation to know about underground work, to know about if there is some other water bodies like lakes may be there, if not something else, streams may be there, depends, and which all affect our work, our designs. So it's not simply that you will take some bearing capacity at 1 meter and finalize. No. That is one of tests we do. The full range soil testing, and I discussed in some page also, some report also long back about soil investigation, what methods are used. I think I did not complete that one. I'll take one day that also again. But there are so many tests we have to conduct. Boreholes we have to take into considerations, and maybe hundreds boreholes, 50 boreholes, depending on which area, which foundation we have to construct. Heavy foundations, deep foundations, machine foundations, vibratory foundations, and which area we have ordinary buildings, which area we have process area, we have electrical buildings, we have some other buildings, center building, control building, and also near sewer we have a lot of requirement for site soil. So soil resistivity test, thermal resistivity, thermal conductance, bearing capacity, and then these boreholes, and you can say a long list, you can say full range test. Then there are so many recommendations for soil, how to use that soil best way, best possible way. This all depends on how you soil investigation. Therefore, very dynamic activity, and this gives you a whole picture of site, and in full range. Not, it may take months or 15 days if you have full scale laboratory. It depends upon what you have. Laboratory may be professional metal testing laboratory. There's all equipment with it, and it will go to site and test. And you have to just give them points where you have just so many holes, and that's where you can say you can manage, you can organize. So this is that part of soil investigation. And then we can say soil improvements as well. Soil improvement after soil investigation. Soil improvement is required where bearing capacity is very low, or where clay exists, or where there are chances of expensive soils are available, and we cannot site our structures on expensive soils. So either because here we are going to fill in whole area due to it is near sea and already low level. So nobody likes to keep a plant at low level due to so many reasons of flooding. So we always raise it as a part of site preparation related. So soil improvement is that part of where you have to remove to some extent weak soil. You have to remove to some extent weak soil and replace with reliable soil in considerable depth so that soil increases. Soil investigation and improvement are related, and we should do investigation as well as improvement by engineered fill or by some other method. You can say whatever method we employ, we can apply that is available in our other books, and we talked before that soil stabilization, you can say that one. That methods can be applied here in soil improvement so that building capacity is raised and other words our water penetration reduced, or we can design soil contents based on various then we can now move to blinding concrete. Blinding concrete. What is blinding concrete? Well, I think many of you know that. What's blinding concrete? It's very simple. It's very, very simple. Only name is little different. Not conversant with our people. They are not conversant with this one. But it's not very difficult. Formation level when we reach and we decide this our formation level, this well compacted. We then, if you want to treat with chemical, that's not necessary, but if you can do it, and then immediately you lay concrete layer, which is you call in our country lane concrete or blinding concrete. Overseas, and it has to close all unevenness of formation level, and it should make one very good layer, smooth and continuous layer, same level below formations, all over site, planned accordingly. This is called boundary. That is called blinding concrete, and blinding concrete is a very important part of foundation on which your waterproofing is done, and that's concrete protection. Waterproofing below ground and above ground, which is a very important item. Concrete protection, waterproofing below ground and above ground. Concrete protection. Why we need protection? Question comes in. Why do we need protection? Do you have an answer? I think none of you may answer this. People generally call it waterproofing. If suppose there is no water, you won't do it, even then you do it. Why it's called waterproofing? Suppose there is no water in some area, but still you have to do waterproofing. What for? That's the point we have to understand. It is concrete for foundations to protect. Already we have given some other task, some other tool, which is, we have to do foundations. Before that we have to waterproof all blinding area like surrounding Almeda. And then we have to see why protection is done. This reason is very important. Why is protection done? Concrete is to be protected from what? And then why do we call it waterproofing? What relations they have got into to each other? Right or not? What is Mm. So protection we are talking of, it's a question here, we have to think of this, no? We have to see what soil is available around concrete, on which concrete is going to rest, what soil is available, what chemical composition the soil has, what water composition soil has, what is expectation, what is possibility that soil can mix with flowing water from around and move. Soil, you can say water soil mobility, that is very chemical technique, or you can say not technique, actually it's a problematic technique, it's a problem creating technique, that water soil moves, water mixes with it, soil, and it moves. That a rogue, you can say it's a rogue, it's a problem which can cause damage to foundation, which can cause damage to, while it goes below footings, it goes on sides, it moves in sides of foundations, it can cause technical problems, uplifting, healing, or taking off soil with it. There can be so many problematic issues when we consider soil water movement. Soil water movement, if we consider, it happens. So we have to take that possibility into our consideration, and we have to see what sort of soil is there, and if it is required that we have to improve soil, we have to replace it and put with granular soil fill or engineer fill below foundation by removing loose soil, or by removing, you know, clay type soil or silt type soil, what sort of foundation it is, what is coming on that foundation, and for that purpose we have to apply protection layer around footings, horizontally and vertically, all surfaces we have to protect from such waterproofing membrane, we call it, or bituminous membranes, so that those chemicals do not touch surface of soils and do not harm these membranes as well, because we have to take further precaution on the membrane by placing some flexible sheet. So these chemicals are kept off, and even if there is water soil movement, is kept off foundations, and that's what we call soil, you can say, concrete protection. And that concrete protection is from soil, from chemicals, and from water, and that's why sometimes we call it waterproofing as well. And that is below ground as well as above ground, in all structures, whatever structures are there. All structures are subject to chemical impact of soil, chemical impact of, because chemicals contained in soil. And that is very much called protection against chemicals, protection against soil, protection against water flow. When water mixes soil, chemical reaction can happen, soil can swell. So we have to take this into consideration, particularly in dry areas as well. The sulfate contents are there, chloride contents are there in our soil structure. So we have to protect all foundations from such chemical impacts, and that's called protection of concrete from such elements, such agencies. And that's why we call it concrete protection, waterproofing, below ground and above ground. It's very important part. This is, best is if you can remove such dirty soil, such harming soil, we remove, and that is best, I think. And to improve soil, that's called soil improvement. Even then we have to take precautionary measures. Then we call cast in situ concrete. Cast in situ concrete. You know what is cast in situ concrete? Nothing new in this. All concrete that is produced on site, all structure concrete that is formed on site, steel placed on site, and then pouring is done on site, all is called cast in situ concrete. RCC slabs, suspended slab, columns, beams, ground floor, graded slab, whatever else, where there is no precasting, there is no precasting element. This is called cast in situ concrete, which is ultimate concrete, and that is forever permanent. And most quality effects are seen there, was quality controls, quality specialization, and techniques, method statements are most importantly required for such cast in situ concrete. It's very important element of, we can say, major component on sites, which takes time, which consumes time more than 50% of project. Cost wise it may be a little less, but otherwise time wise it's much more, and sometimes cost wise also it's much more. You can say all activities of cast in situ are from foundations onto top of parapet to whole stories, and even infrastructure work or attached buildings, associated buildings. You know, it may be plant building, it may be process area buildings, or foundations, or tabletops, or piping. You can say duct banks, manholes. You can say as much as can say this is cast in situ concrete. Big element on project. Lakhs of cubic meters, thousands of cubic meters are done on sites. Such activities are done, and really this must be taken care of. Everything is done for cast in situ concrete. And then come on to formworks, all types. When there's cast in situ concrete, of course this is related to cost. Because related to formwork, we have to produce formworks, then we have to put in steel and services, and then we say you put the services inserts, and this is called cast in concrete. Pour after that, and of course related to reinforcement fabrication. Reinforcement fabrications, cutting and bending, reinforcing bars, and also reinforcement placements. How do we do that? Place on site, on spaces, and in position. So these are all linked. Cast in situ concrete is linked to formwork, and formwork is linked to reinforcement fabrication, and reinforcement fabrication is linked to reinforcement placement. Then precast, pre-stressed concrete, if we include it, let's say now precast, pre-stressed concrete. In reinforcement fabrication, we have various options: cut and set, cut and bend, and then overlap if required, or we can say no, we don't want overlap, we want a professional work. Or of course overlap is also professional, but for ease of convenience we can say we use mechanical connectors for higher diameter bar, say 20 mm diameter or more. Those I think overlaps not preferable, those high size bar. If you say 10, 12, so okay, we can place for them as well, but it's better if you, because we use some connectors, mechanical connectors for those high diameter bars which are available. These connectors can either bars in tensions, bars are in tensions or in compression. Connectors are available and we can connect them, provided we test further. We test samples that these connectors give maximum tensile strength, is not impacted upon. If that is worth, we can use connectors, mechanical connectors for joining these two bars without overlapping. And also we have to keep in mind, if we are using reinforcement of all sizes, and there's a chances that reinforcement is rusted due to moisture ingress on this, which must be taken care of. We don't allow any moisture, we don't allow any corrosion, we don't have red color steel. on projects, industrial projects or other projects, we have to take care of that bars come in exact clean position, clear color of a steel, and we have to protect it on site in yards, keeping off ground by providing some platform below and store it properly, protect it by cover of polythene. And if there's a problem in this case, rusting is not avoidable. Otherwise, use coated bars or epoxy coated bars so that there's no attack of moisture on this. But point lies in that if you are going to use cathodic protection on that, then you cannot use cathodic protection on such bars. If cathodic protection is not required, generally in plants you will see cathodic protection is a measure. So there you have to use only bars without coating. And there are ways of cathodic protection which is critical and non-critical. Anode sacrificial anodes are used. In those cases, you have to be careful about that your steel should not be impacted by moisture. No reinforcement is allowed to be rusted. It may be cast in situ or precast, whatever. And then you have to see pre-stressed concrete if included, generally on plants, on big plants where blast also is. Yeah, it's not banned, but generally we prefer cast in situ concrete. It's better. Pre-stressed concrete is rarely used there, but not banned if joints are taken care of, if diaphragm action is taken care of. This are allowed. Concrete, as I said, precast means if it's not pre-stress, I'm talking openly. Precasting means not casting on site but casting in yard. So that's not pre-stressing, that's only same precast members, just cast in yard and transport it to location. We have to just take care of handling stresses in that, nothing else. Additional handling where crane has to lift them and put them in a trailer, and then crane has to offlift, unload from trailer, place in site. So those additional stresses must be taken care of. The concrete class, what class of concrete it is, grade of concrete, or maybe other considerations like colored concrete. What's important is grade of concrete. That's important. Or maybe when we talk about structural concrete, say enough, and which grade it is, what's and then reinforcement grade. Let's say kind of many grades of reinforcements are available. All grades, which grade we have to means market BS grade, or we have to 4499 it was, I think, on time. Then structural steel we have to take care of. Structural steel also a big component on plants. Structural steel generally you can say on industrial plants or where equipment come in, all equipment are housed in buildings of structural steel and sheeting vertical and roofing. Structural steel is used because these are industrial structures and it's easy to erect, and this structural steel is less expensive than concrete. So structural steel is used on various industrial products. Then important point is structural steel, though it's used for superstructure, for its foundations, for its substructure, generally RCC, cast in situ, is used. These structural steel columns or stanchions rest on bolts. These bolts are left in foundations, or pockets are left here, voids are left here, which are routed. Generally that way all pipe racks may be of structural steel, or all sheds or housing of machines may be structural steel. There are various components where structural steel can be. Erection means not difficult, mechanical erection. Just framing is erected and then secondary members are left. Of course, soil backfill is very important part. Backfill is very important part because backfill means a big and time consuming activity, because soil backfill, it's is short term activity. It is, and we have to backfill and compact, and we need soil for that purpose. It's not that what we excavate we can backfill that. It's not that. We have to produce that type of soil which is good for that which is good, which is reliable for that project, for that. Means you cannot simply use soil without testing, or you have to create a design mix of backfill soil by importing some soil from elsewhere and grading out and mix out various to produce some grading, granular. You can say grading you have to produce. That grading means how many percent you have to import and mix, so that compaction is easy without any harmful materials, no organic materials. And then consolidation, though it's not necessary in that case, but in long term consolidation does happen, maybe in 15 years, 20 years, 40 years. So that point you have to keep in mind. So it's a kind of granular mix where there's a proportion of fine particles, coarse particles getting fine, so that it's completely filled in the packed. It's completely packed without any considerable percentage of voids which allow water to flow in. Permeability may be allowed, but porosity is not accepted. And compaction is done in layers. It's filled in layers, a maximum 150 mm thick, from 200 thick, and machine compaction or otherwise 98% product density is acceptable below structures, whereas otherwise no structure area also can be where there's no expectation loads, but 95% possibly. In general fill it be 90%. So 98% is minimum it should get. And soil backfill is of course the important one. There's no settlement future, and this is a really extraordinary activity where people in our country here don't care, but it's most important, soil backfill. We may call engineered fill if possible. You can do engineered fill below heavy foundations, rather ordinary backfill. Engineered fill is granular, aggregates means rock fill, and voids with other smaller pieces of rock fill, and then dust and packed it, so that immediately it takes its density after compaction, and it has enough bearing capacity to resist load and increase bearing capacity, safe bearing capacity would work for foundation. That's what it is called. Backfill is very big component of time related. Then you come to piping all types. It's plant item, piping all types, blow piping, above piping, whatever it is, steel pipe, ductile iron pipe, or GRP pipe, you can say these epoxy GRE pipes also are there. Then those pipes are not these days available, stoneware pipes, and those, big pipes, water pipes or water pipes for gases, and whatever pipes for so many other requirements. RCC pressure pipe, non-pressure pipe, and or you can say pressure pipes, of course. Then building pipes, very minor level pipes on manholes when the services are there. Services, many kilometers of services, catch basin, manholes, catch basin, this. All pipes below. Without pipes, nothing is many kilometers of pipes, all categories, stormwater, catch basins, there is piping. Everywhere there is piping. So then concrete block walls. Concrete block, we all know concrete block. precast concrete block, 9 Newton means 9 Newton per square millimeter, which is capacity of block, that is projected area of block multiplied by that newtons, you get total strength of bar. It's not hollow space, it's not in concrete grade, it's projected area grade, and if it's solid bar, fine, that will give you total area. So it's precast one, and these blocks are manufactured in factory and delivered to site. This is concrete block walls, hollow blocks or solid blocks both. We know well this is not generally load bearing, these are ordinary cladding one. Cladding purpose they are used after framing is done. When framing is done, walls are constructed of walls, block walls, according to designs. And then roofing, all involved types. Roofing is very different activity, very important activity as well, because this is used for purpose of rainwater prevention, flow out drain, and also for purpose of thermal conductivity. Thermal insulation. Thermal insulation, and of course foam concrete is involved with that. So this we have to take care of very well. Roofing item is very important, though it's only one floor on roof, not all floors. And this drains out rainwater through, you can say, gargoyles or through pipe, inlet pipes and out down. And water, we must take care of that slab after doing waterproofing, that water tightness must exist. Actually it's called inverted roof system of roofing. It's called, there's a foam concrete. Foam concrete is sprayed, or very light, very lean concrete, cement mortar is done. Both can be, but because foam concrete is very light, it's preferable, and it's watertight as well. It's done in grade, and above that we can take all waterproofing, roof wall system, and that's place of further one. Whatever finishes, tile finish in accessible areas, and granular fill in non-accessible areas, and then we can protect parapets by flashing, aluminum flashings, etc. with complete sealing, and that's what we can say is about roofing. All involved types, where there is pitch roof, means it's not necessarily roofing in that case, ordinary roofing. And plastering and rendering, very intelligent item. Plastering and rendering we'll talk of, and it's really very important item, because plastering for internal areas and rendering for external areas. We'll take of it later on, because it's also in details. There is flooring, all types including raised one. There is blast door, and there are doors, windows, ironmongery, kitchen including names. All this will take up. Of course, now we cannot explain everything in one day. So what I'm saying is, this is about, we are dealing with many items of buildings on structures. We'll take up from plastering next time. And this all topic I'm sharing my experience based information with you, for purpose that we should keep in mind that engineering is very wide in scope. Depending on what project you have to deal with that, and that's very important part of our projects. All these items, these may vary from project to project, but on plants where big areas are available, block plots are available, kilometers by kilometers of site, you have a big site, a big plot, and big, all types of buildings, all types of foundations, all types of internal access roads, internal service roads, other roads. And I don't think something's left in such projects. Of course, it is interesting to note that, and it must be valued from engineering point of view, as I've experienced and learned a lot practical aspect from those. I worked in one plant in Doha, that was LNG plant. Of course, I did not work much there. I had two projects there. One was for plant look after, that was for records of service, and another was for villa. Well, I worked in one plant that was in you can say Ruwais, Abu Dhabi, where I would stay on that project for 3 or 4 years on that plant site. Enjoyed desert life, enjoyed desert life in Doha as well. Then I worked, I learned a lot on that project in Doha. Sorry, not Doha, this Abu Dhabi for 3 years, where I learned a lot of coordination on such projects, hundreds and thousands of drawings. And there I produced a lot on myself, on my reliability without having any extensive support. And then I like this, lot of experience I have grabbed. I like to live it here because we have to move further now. I think I will thank you very much this time. I'll take off later on now because it's now it's now done here, and I take your leave for your kind cooperation. Thank you very much, gentlemen. I'll meet you again. I hope you